So I would like to introduce you to Dr. Oksana Tarasova, Senior Scientific Officer at the UN World Meteorological Organization. Oksana has 15 years of experience in atmospheric sciences, climate change, and greenhouse gas research. She plays a pivotal role in global climate initiatives and policy development.
Yeah, also Oksana has been advanced in the development of World Meteorological Organization, Global Greenhouse Gas Watch, and has led international climate collaboration, bringing science, policy, and global governance. Her expertise lies in transforming climate research into actionable strategies for businesses, policymakers, and global institutions.
And particularly, Oksana will guide us through the key climate-related topics today: the state of the climate 2024, emissions trends and reduction strategies, and the role of carbon measurement and reporting. So, Oksana, thank you for being with us, and over to you.
Thank you, and please be clear when to check the slide.
Yeah,
okay.
I'll try to do so. Thank you very much, Audrey. What you said is extremely important, because if we move to the first slide, the title of my presentation is The Forgotten Part of the Environmental Sustainability, which is actually the state of environment itself. It's never considered in any economic strategies or any financial or planning strategies. And why it needs to be considered, let me just have an explanation of where we go. So if you look at the state of environment from the perspective of climate change, which would be, let's say, one of the biggest drivers of the changes as we see it now, we can see that in 2024, let's say the 9 months of 24, we had an increase over the pre-industrial time of 1.54 degrees. And you would say immediately, wow, that's already like what we discussed in Paris Agreement. True. The ocean in 24 or 23 absorbed 18 times energy of the whole global energy consumption in the world, which means if you stop emission tomorrow, we have enough energy in the ocean to drive a lot of changes, even if we don't do anything. And a sea level rise within the last 10 years has accelerated. So we can see in 2023, the increase of about 5 millimeters per year, which is absolutely critical for some coastal communities. Next slide. So why should we be concerned about the climate change? Well, we've seen the report from Global Risk Assessment. And yes, on 2-year time horizon, the extreme weather events are considered as one of the most critical risks, or number 2. Why? Well, between 1970 and 2021, there was about 12,000 reported disasters, with over 2 million deaths and 4.3 trillion economic loss. This loss cannot be ignored. It does impact business practices. And if we move further on a 10-year time horizon, no, previous slide. So if we move further into the 10-year time horizon, we can see that actually extreme weather events, biodiversity loss, the critical changes in our system, in the natural resources shortages, which are all environmental risks, they are becoming the top risks on a 10-year time horizon. Next one. So what do we agree? We do realize that environment and climate change do have an impact on basically living of humanity on this planet. That's why we forged the Paris Agreement. And actually, even before that, in 1994, we adopted the United Nations Framework Convention for Climate Change. So what did we say in the Paris Agreement? We wanted to limit global average temperature below 2 degrees and pursue efforts of 1.5 degree, which were actually breached in previous year. And how do we do that? We do it through the balance between anthropogenic emissions and removal by sinks. So there are actually 2 parts of the equation: what you put in the atmosphere, because this is where the changes happen, and what you remove from the atmosphere. How do we do that? All the countries take the commitments, which called national determined contribution. And even if you start involving carbon markets, which is going under Article 6, you still need to get a total mitigation. Mitigation means emission reduction. So there should be complementarity of what you do for carbon market to the traditional emission reductions. In Article 13 talks about enhanced transparency. You need actually to see if the actions which you are taking are having any impact on the environment or not. And given the fact that we knew about climate change, we forged the convention in 1995. By the time when we get from the convention itself to Paris Agreement, we already increased concentration of CO2 in the atmosphere by 10%. Is it ignorance? Or is it a lack of leadership? This is both. So why do we look at CO2? Next slide. CO2 is the most important anthropogenic greenhouse gas. So it provides majority of the forcing in the atmosphere, and it's the major driver of climate change. So what happens with CO2 is that actually CO2 is a part of the natural big carbon cycle. So we have the biosphere, which is exchanging carbon over the atmosphere. We have the ocean. And what happens is that when we put emissions in the atmosphere by burning fossil fuel, we produce about 36 gigatons CO2 of emissions in the atmosphere every year. So we just pump CO2 in the atmosphere. What happens is about 30% is taken by the plants. So they use CO2 for the photosynthetic activity. So they actually do the 30% offset on our emission. And then due to the mixing with the ocean, you have another 26% reduction on the emission. So it's only 50% that remains in the atmosphere and drives climate change. Can you imagine what happens if both the biosphere and ocean switch off? The situation will be really dire. Next slide. So what do we do with emissions? I mean, I told you that we forged the convention in 1994. We knew that emissions are bad. We knew that they impact the levels of greenhouse gases in atmosphere and climate change. And we've done very well. We increased our emissions by 80% between 1990 and 2024. Well done, humanity. And where does it come from? If we look at the whole spectrum of emissions, we can see that majority of emissions are all greenhouse gases, which are expressed as CO2 equivalent. So you add to CO2 emissions of methane, nitrous oxide, and some other gases. So if we look at the profile of emissions, majority are associated with energy sector. And there's plenty of opportunity to actually tackle that sector and tackle the transport, buildings, fuel production, as well as agricultural processes and waste management and LULUCF. It's not a rocket science. There's plenty of strategy how to do that. And basically, if we do not bend the emission curve by 2030, we are done with 1.5. And we have very small chances to actually limit our temperature increase below 2 degrees by the end of the century. Next slide. So what can we do? There's plenty of strategies which are developed by the scientific community, which are talking about what you should do to address emission reductions. For example, there is a big coalition which is called Climate and Clean Air Coalition that includes countries, that includes the non-state stakeholders and different organizations that provided plenty of guidelines on how you can reduce short-lived climate pollutants. That includes methane, nitrous oxide, and the aerosol particles in the atmosphere. And there are solutions which are offered for different sectors. For example, in the fossil fuel sector, you just need to prevent the leakages of methane in the atmosphere. This is better than just ventilate everything out. In the case of all the other sectors, for example, electricity supply, industry, transportation, buildings, for businesses, you have plenty of solutions. For example, planning the move to the 100% renewable electricity in the future, plan and implement zero emission transformation, or use the long-lived products, look at the whole circular economy and do the reuse and use the products which has been used in a chain that you can actually reduce your impacts on the environment. So there's plenty of those strategies. The question is why they're not used. Next slide. And when you talk about all those different strategies, the one thing which you need to know, and this is what Audrey has been talking about, is that how do you actually then estimate your emissions? And the traditional way to estimate the emissions which are associated with activity is a pure statistical approach. And why I say pure statistical approach is that, well, actually it has nothing to do with environment. It does not take any information from the impact of your activity on the environment. It's a human statistical information. You calculate the number of the activities, like I can calculate number of cows, I multiply them by a number which is called emission factor, which can be measured in the lab, or once measured in one stack or in one industry. And IPCC has a lot of default emission factors. Then you multiply one by the other, you do the sum, and here we go. You have a national total emission estimate. You can use tier 2 and tier 3 to get your national emission factors, which is better than default, and many countries don't use even that. Next slide. When it comes to corporate, the approach is exactly the same. So you have scope 1, which is direct emissions, scope 2, 3, indirect emissions, but you do exactly the same approach as on a national scale. So you just do the statistics, calculate the number of the tons of the product you produce, multiply by emission factors, and here we go. Also, it is not very clear how you compare what you calculate on a national statistics versus what you calculate on the corporate statistics. But as you can see, there is no state of environment in those equations. Is it important? Probably yes. Next slide, please. We can use actually the state of environment to understand the emissions. For example, we can put a station which measures the number of the molecules of a certain gas in the atmosphere. And then you use the modeling, which is actually moving those gases just like a weather forecast, but backwards, towards understanding where do they come from. And from that, you can understand your emissions. The advantage is that it's objective. You cannot do double counting. You cannot do the cheating because you have an instrument which measures concentration, and then you get to the emission. Next slide. Is there any difference between what you do with inventory and what you do with observations? Here's an example. This is an example of evaluation of land use land cover emissions in New Zealand. So there are two stations which are performing the long-term measurements of greenhouse gases. They measure CO2. Then we do the footprint. It's like, where does the air come from? And then we have what the statistics give us, and we call it the prior emissions. So we combine three together. Next slide. And what do we see? Well, actually, we see a substantial difference. The green one is what we see in the observations, and the gray one is what you do see in inventory. You can see that from observation, we can see much larger uptake of CO2 than you see in inventory. And actually, it happens in the different areas. It happens in the areas of indigenous forests, which drove New Zealand to actually put in their first emission reduction plan the preference for indigenous forest for climate purposes and not the fast-growing plantation, which is usually used for carbon credits. Next slide. And this is another area in Brazil where the carbon credits are generated. And we are doing measurements there as well. So if you look at the zone 1, 2, and 3, in all those areas, you have the measurements of greenhouse gases using the vertical profile. And what observations show is that Amazon in the last 5 years turned from absorbing CO2 to emitting 0.5 gigaton of CO2 per year. People buy carbon credits. There is no offset. It's just emitting as in any other emitting activity. Next slide. And the worst come to worse. The national commitments, which are the national determined contribution, about 118 countries explicitly rely on achieving their climate commitments through forestry. Climate feedback is not taken into consideration in those commitments. Next slide. And for the companies who actually want to be carbon neutral, they rely on carbon dioxide removal. So if we look at the report which is related to carbon dioxide removal in 2024, most of this carbon dioxide removal, 2 gigaton, comes from forest. It's a conventional carbon dioxide removal on the land. The worst thing is that there's 102 MRV protocols, which are used for verification of those offsets. You can't even compare them with each other. So what can we do with that? Next slide. The actions for today, as articulated in the Global Risk Report, is to improve monitoring, reporting, and evaluation. We cannot run the full speed against the wall, not knowing what we're doing and what impact we have. And we need to strengthen regulatory framework and unlock ambitious funding. World Meteorological Organization is there with the whole network and the standards and observational-based quantification. We would like to help businesses to understand what real impact they have on the environment and help with their planning. Thank you.
Thank you very much, Oksana. Thank you for the methodology. I hope that more and more businesses will be collaborating with you. I know that there are a lot of questions for you from different speakers, but I would like to transfer everything to Mikhail. We have time for one question, right? Can you share with us?
Yeah, but Oksana, thanks a lot for the eye-opening presentation, and I have just one question. With the increasing regulations around emissions reporting, what are the biggest challenges you see which corporations face in accurately measuring and disclosing the carbon footprint? Because it's always a question, is it like 10 or 12 or, I mean, yeah, so what's the accuracy is always a question.
Well, for some emission categories, for example, related to energy production, the calculations are pretty good because you can do the calculation based on the burned tons of fossil fuel. For others, for example, if you move to agriculture or if you move to forestry, the uncertainties are 80% on any estimate if you do the statistical information. So that's why we introduced the measurement-based approach where you can do the direct assessment of what happens in the atmosphere because it may be different from what is happening. And what we've seen, the very unfortunate tendency, which we've seen is that many countries or enterprises actually can choose between our tier 1, tier 2, or tier 3 reporting. And oftentimes what you see is that exactly what Audrey said, there's a lot of cheating happening, and I call it cheating because countries and companies say, we will choose the approach which actually gives me the lowest emission possible. And that's why there's like 105 protocols for the uptake verification and carbon dioxide removal. And you can choose what is convenient for you. You can go varied, you can go gold standard, you can go whatever you want. So given that the economic damages from climate change are substantial and will only increase in the future, we are not getting better. They will increase exponentially. Probably it's time for businesses to look on the objective quantification, what you guys do, and put investment where actually we do understand what is your environmental impact objectively and not just on the paper.
We will reinforce and share this message once again across all our network and specifically to our business partners that are collaborating with the Global Impact Alliance. And I guess, Michael, we can move forward.
Yeah, we will move further, and just again, the insights which really reinforce the urgent need for businesses to integrate climate action in the ESG strategies. And now we're move further with another critical aspect of sustainability, natural resource management, and ESG education. And to guide us through this, I'm pleased to introduce Yulia Koroleva, my good friend, Head of Sustainability at the Global Impact Alliance. With over 15 years of experience in sustainability leadership, education, and corporate strategy, Yulia has worked extensively with international organizations, academia, and businesses to promote responsible resources and resources use and ESG integrations. So today, Yulia will discuss the role of natural resource management in ESG, why companies must rethink supply chains, biodiversity impact, and ethical sourcing, and key ESG trends, challenges, and opportunities in education, how business schools, corporations, and policymakers are shaping the next. Well, I hand it over to you, Yulia, and hope to dive deeper in this crucial ESG theme. So the stage is
Thank you.
yours.
Thank you very much, Michael, for such a beautiful introduction. And I guess we can move further with the slides, right?